Hello everyone, welcome to this series of machine learning algorithm. And the first algorithm which we are going to learn is linear regression. So this is the very foundation of the machine learning. Let us understand what does this algorithm do. Consider a data set which is consisting of two features: the size of the house in square feet, and we can take the price of the house in lakhs of rupees. These are our two data features, and we can take the corresponding values for, let's say, for 1000 feet square, the price is 20 lakhs. For 1500 feet square, the price is 23. For 1700, the price comes out to be 28. And for 3000, the price is 29. For 2500, it goes to 31. So these are the data that we are having. Now, if I ask you a question that can you predict the price of house whose size is equal to, let us take 2246 feet square. This is the question. Now, to find out the price based on the given size, what we do, we try to train the model using the algorithm which is called as the linear regression algorithm. Now, how does it works? Basically, we try to plot this data set in XY plane. Consider this first feature as X value and the second feature as Y value. So this will form a pair. So like for 1000 feet square, we have the price as 20 lakhs rupees. We can represent them using the coordinate pair 1000, 20. Like this, every data set can be represented as a point in the XY plane. So if I plot them in the XY plane, so this is x-axis, which is nothing but the size of the house, and on the y-axis, we have the corresponding price. If we plot this point, let us take these are our data points. Our aim is to find out a line which best fits this data. What does that mean now? Like if these are our actual data points, the cross ones, and corresponding to that, we have these orange points which are on the line. They are nothing but they are the predicted point. So the actual point and these are the predicted point. What is the distance between that? That is represented by these vertical lines. So these are the distances between the actual point and the predicted point. Our aim is to find the line such that the distance, sum of the distances from the actual and the predicted point is minimum. That line will be our linear regression model. There can be many lines. Let's say this can be the another line. Then we can have another line. So which is the best fit line? That means in which case the total distances between the predicted and the actual point is minimum. That will be the best model for our algorithm, which is linear regression. So how to find out that line? That is a question which we are going to explore in the video. Let us proceed further. Now, let us talk about the equations of line. We have all have studied the equation as y is equals to mx plus c. In machine learning, we usually denote this as h theta of x is equals to theta 0 plus theta 1 times x. We are going to use this equation of the line. Basically, these two are same only. Just the notation has changed. The meaning remains the same. Now, if I plot a point, let's say this is the point here. This is our x and y axis. I'm plotting a point or a line. Whatever the distance is cut along the y axis, this is called as the y intercept denoted by theta 0. So this line has cut this much length along the y-axis. So that much length is nothing but theta 0 to find. So theta 0 is nothing but our y-intercept, which we can find usually by substituting x equal to 0 in the equations. What about theta 1? This is nothing but the slope of the line, or we can say it is the coefficient. What does that mean now? Let us plot again the same line. Let's say we are changing x by a unit length. Then what will be the change in y? Change in y as we are changing x is nothing but our slope. In this case, that is represented by theta 1. So slope is nothing but it helps us to find out the change in y when we change the x by a unit length. So these are the meaning of theta naught and theta 1. Now what about x and h theta of x? X is our independent variable, whereas h theta of x, since it depends on x, whatever will be the value of x, correspondingly we will get the value of h theta of x. So this is our dependent variable. So this is all about the line, intercept, slope, dependent and independent variable. Now, what was our aim? So our aim in the linear regression algorithm is to minimize the distance between the actual and the predicted point. This we should not call between the actual and the predicted. Sorry, this is and here predicted points. Let us understand it one more time because that is the important part. This is our y-axis, this is the x-axis. And let us plot the data points. So these are our, let us say, 4 or 5 data points. If we get a line like this, then these are the distances between the actual and the predicted point, which is denoted by the dot. Correct? Our aim is to minimize the distances. And mind you that this cross one are the actual points or the actual output, and corresponding value of x and y on the line is nothing but it is the predicted point. So we define something called as the cost function. Cost function is what? It is denoted usually by j, and it has two parameters, theta naught and theta 1. Now, what does that mean? How it is defined basically? It is the sum of the distances between the points. So we know that our predicted point is this line, which is h theta of x is equals to theta 0 plus theta 1 times x. So we have h theta of x. Since we have data point, many data points, what does that mean? We have data like this, x and y. So here we have some value, here we have some value. So this will form our first pair like this. x1, it can be written as x1 comma y1. Then the second pair of data will be denoted as x2, y2. So in general, we are denoting it as xi. So h theta of xi is our predicted output minus yi is our, here you can see this one. It is our actual output. Now, we take the square of it and then we take the average of it. So this average of the square of the distances between the actual and the predicted point is what we have to minimize. We further divide by a factor of 2. The reason for that is we know that whenever we study about minimizing a function, what we do, we generally equate its derivative equal to 0, or we need to find out the derivative of the function. From there, we try to minimize it. And here we have a square. Can you see this? A square of this distances. So if we try to find out the derivative, let us say x square, we are having a function. And if we find out the derivative, it is 2x. The reason behind dividing it by 2 is to cancel this factor 2, which simplifies our calculation. So that is the basic reason we divide it by 2. Because if we take the derivative of j theta naught theta 1, 2 will be in front, this power. And to cancel that 2, we are dividing this factor 2 here. So that is the reason. And this is the definition of the cost function, which we need to minimize. So for what value of theta naught and theta 1, we are going to get the minimum distance, that corresponding line with these value of theta naught and theta 1 will be our best fit line. That is our aim. We will continue in the next part of the video on how to find the best fit line. Hope you understood the concept here. Thank you for watching.